I'm Avinash, and so we are here for taking up this course, CS224, which is on NLP, and it is by Stanford. So the course instructors will be Chris Manning and Abhijal C. So I actually took this course, the 2017 version of it, some time back. It's been longer. It's been like more than 1.5 years since I took that course. I didn't work on assignments when I did that, but I did go through all the lectures, all the videos. So yeah, here we have the course page. So we have the lecture videos, and we have all the stuff related to the course here. Okay. Yeah, let me see.
If you click on participants, right on the list, you can see mute all.
More.
If you take your pointer up, right where you have this option,
Yeah.
of the list.
Avinash, can you just mute all the
Yeah,
Sure.
If you hover your mouse there, you should see the participant button. Click on that. Right below the list, there should be a mute all button.
Right below the list here.
Do you see the participant list?
Participant, yeah.
There should be a button to mute all.
Yeah, mute all. Yes, I just did.
Thank you.
Yeah, no problem. Yeah, so I just muted everybody. So if you have something to ask or say, feel free to unmute yourself. So yeah, the course page has some prerequisites, like the course uses Python and PyTorch. Previously, the 2017 version, they were using TensorFlow, but for this version, for the 2019 thing, they moved to PyTorch. And so some of the prerequisites which are mentioned in the course page are like calculus, linear algebra, probability and statistics, and some ML basics. Having said that, it's not like you really need all these things, because when I took the course, I didn't really find it that hard following all the math part that was there in the course. There are some lectures which have some which are quite heavy on math content, but what I found really helpful is that the course here, this course has lecture notes, and like the lecture videos are itself, like they're very good. Christopher Manning, like he explains things pretty well, and then every like all the lectures also have lecture notes. I think both of these like complement each other very well. Like if there is anything in the lecture that you didn't quite understand, chances are that the lecture notes will help you understand the things better. So if you really want to make the most out of this course, I think in addition to going through the lecture videos, you should for sure go through the lecture notes. They are like very good. They also have some different textbooks here. Yeah, and here we have all the videos on YouTube. There are like 20, and these videos also include 3 guest speaker lectures. One of them is by Richard Sosha, who was also one of the instructors in 2017 version of the course. So each video is like around 1 hour 20 minutes, and yeah, and also there are like 5 assignments which are publicly available. The code is there, and if you have taken deeplearning.ai course, the specialization on deep learning by Andrew Ng, they have these notebook kind of assignments where they have some code and then they leave portions of it for the students to finish. So I went through like 1 or 2 assignments, and they have something similar here as well. They have notebooks, and they have portions that have to be finished by the students. So there are 5 assignments, and they are publicly available, so we can take them up as well, and we can work on those. And
Just to add a small information here. So if you search in GitHub, you can get the solutions also. So if you really like need the solutions to understand the code or something, and you don't have the time to write the code for the assignments.
yeah, thanks, Sam. So yeah, I think we will easily find some solutions on GitHub. But
I hope like it's since it's 20 weeks, we could maybe collaborate on the homeworks. Take it.
yeah,
Amazing.
that's what even I'm thinking. Like I think the unlike like we primarily have been working on computer vision like for most of
Right.
the part of fast AI. So
Okay.
if we really want to make the most out of this in that time and efforts and work on these assignments, that would I think really help us with really knowing and understanding the stuff.
Avinash, a quick question to you.
Yeah.
Have you had the chance to check out the FastAI NLP repo? Like, how do these two courses compare in terms of the syllabus?
Not yet, Sanyam, but yeah, I'll do that. And since I already took the course, the previous version, maybe I can compare and see like what extra we have in either of these courses.
Would
Sure,
love
I'll
to
do
hear
that.
that. From
Sure.
what I know, FastAI is very beginner focused. So like it starts from somewhere around the part 1 zone, unlike the part 2 zone,
Okay.
and
Okay.
builds on NLP concepts.
Okay, so here, if we see the first few lectures are like they don't get into the neural network stuff. They don't get into deep learning. They start with how we got what to wear, glove, and all these things. And then I think like after the first few lectures, that's where they really get into RNNs. So until then, it's about word vectors and back propagation and all these things. So when I took this course, I didn't really have any prior knowledge on NLP. So this was the course which I got started with when it comes to NLP. Uh, as far as I can remember, I did have to like put some efforts in going through the suggested readings and some things from Google, but these lectures were really good. Like they really helped me understand what actually happens with NLP and some of the things. So yeah, but yeah, we can surely check Fast AI also, and we can compare, and then maybe we can plan things better.
Sure. FastAI for the audience, it comes out somewhere late in July. If
Okay.
in the interest of the group, we could take that after we finish this course.
Sure. Yeah, that sounds good. Yeah.
Another quick comment, like
Yeah.
contrary to what we think, glove, word to wake, such things are still relevant, especially if you take the world of Kaggle.
Yeah.
Like not everything is just LSTM, BERT, etc. Those things also matters. So having an
True.
understanding of those is very helpful out there also.
Yeah, I think the first few lectures actually help us in clearly understanding like, so basically whether it's image or text, I think all these data has to be like transformed into some sort of number representation.
Right.
So yeah, so Word2X and all, they help us, the first few lectures help us in visualizing and understanding things like how it happens for text, because we read a lot and we work a lot on images and videos, but when it comes to text, things are a little different.
Right.
But I think the first few lectures are very good, and they help us in knowing these things. Yeah, so all the lecture slides are also available, and as I said, you have to check out the lecture notes. They are very good. So now that we have like 20 lectures, and each one is around 1.5 hours or something. And so I just wanted to ask, like, how do you people want to do it? Like, how many lectures are we going to do every Saturday? That's the first question that I wanted to ask.
We had for the audience, we had a discussion. We're open to both options, doing 2 lectures a week one lecture a week, but keep in mind that that would be a 20-week-ish commitment, maybe 21-week commitment.
Yeah.
We're also happy to do 2 lectures a week, whatever is in the best interest of the group.
Yeah. So I think maybe if people can respond on chat or.
I'm monitoring the chat.
Sure.
Rekil Prashant mentions 1 lecture and 1 assignment discussion. Are the assignments and lectures equi-numbered, or is assignments?
No, assignments are only 5.
Okay.
Yeah.
So like it's I think it's a bunch of lectures against 1 assignment, right?
Yes. So we have the first assignment for lecture 1, lecture 2 has nothing, and then we have, so it's like that. I think towards the end of the course, we don't have like 1, 2, 3, 4, 5, 6. For the last 6 lectures, there is no assignment.
Right. Rijul, I sort of echo with Rijul. We can maybe decide based on the difficulty level. So I would assume the initial lectures maybe can take even 2.5 a week, then slow down later on.
Yeah. So please go on.
I think like that would cut it down from 20 weeks to 9-10 weeks-ish, if we can.
Yeah, that makes sense.
Yeah. So what we can do is maybe we can target for 2 lectures every week. And then if we are crossing the time, we can always push it to the next week. Like if we are having some more in-depth discussions or the content is heavier in any of those lectures, then maybe we can have whatever the thing that was left of in the next week.
Makes sense. There's a universal yes in the chat. Avinash, would it make sense to take 3 lectures? Would it even be possible for the initial?
I don't think so. 3 lectures would be possible.
I don't think, I'd like to make the comment here. This is a Stanford class. It's very difficult. It's not, they don't, they don't make allowance for the fact that you're not a Stanford student. I don't think we should try to push 3 lectures, 2 lectures. I think we should just do 1 lecture at a time and just see how that goes.
Yeah.
We're fast-A students. We're not just Stanford students.
Yeah, Stanford students are extremely smart. Just believe that. I mean, if you took Andrew Ng's class, the deep learning.ai, he has 5 classes, right? And they're 4 or 5 weeks each. That's 20 weeks. Stanford, they run the same class, but they do all that in the first 5 weeks. And then the rest of the 5 weeks is for a project. So just, keep that in mind.
Sure. I would suggest like let's try 2 lectures a week. Hey, we're fast-A students. We're not too bad either.
I still think 1 lecture a week is plenty.
Mm-hmm. That comment comes from the fact that we might be accustomed with a few basics. So for the first few lectures, that might be helpful.
I'm not sure about that. These lectures are going to be dense, believe me.
Okay. Again, it's open to the audience. I'm fine with either. Again, like that'll take 20 weeks. I'm open to that for sure.
For the first lecture, I can give you a little pointer. So like first lecture is overly covers this bit of logistics and the history. So first and 2 can be clubbed easily, I think. But after that, I'm not sure.
Yeah, the first 2 lectures can be like can be done in 1 week, maybe the coming week. But as we go, the further lectures, I think they would take some time. Yeah, but that again, as I said, it's not like, I mean, these study groups are like kind of flexible, so we can aim for 2, and when it doesn't work, we can always cover the rest of the things in the upcoming next week session.
Sounds good to me.
Yeah. So do we have anyone else who wants to add anything here?
Just to have a discussion. So like how do we going to follow the lectures? Like is somebody making a slides or something, or like slides in the sense some kind of summary of the lecture, and then we'll discuss, or we will start on the fly?
Yeah, Sam. So what we'll do is I can contribute to that. Like I can prepare the notes or slides. So it may not always be slides. Like if you see here, it could be something like this where, so I can get together the notes and like overview of the lectures. And if anyone else,
I can also help you with that. So like preparing the notes and all.
Sure. Yeah. So what we can do is, let's say we have lecture 1 and lecture 2 for the upcoming week. We can split it among ourselves so that one person will be taking lecture 1 and the other person will be taking lecture 2, and then we'll have another person who can walk us through the code. So that's what we can do. But yeah, I'm open for any other suggestions if.
I liked your idea. So that will actually cover like from the all multimodal learning.
Okay. Yeah.
Yeah.
So Sanyam, what do you think?
I'm fine with either approaches, honestly.
Okay, yeah, sure. I'll be preparing a sheet and we can share it across, and we'll see if anybody wants to take up and like present the next week's
Sure.
lecture or something. They can surely chip in. Yeah.
For sure. If anyone else wants to volunteer to present, please ping me or Avinash.
Yeah, sure. Yeah, please do. Yeah. So, and another thing is the assignments in this course are in PyTorch. So if anyone is interested in doing it in TensorFlow, it's just an open question, not that we should do it. It's just to know the interest of the people, like if there are any TensorFlow enthusiasts here.
Do you know of the version? Like, would it be relevant in still, or like with 2.0 coming out? Will there be
Yeah.
any?
That I'm not sure. Maybe we can check it, but I don't know the reason why they have switched to PyTorch. Like one the reason could be that people started finding PyTorch much easier than TensorFlow. That's one reason I
Yeah,
believe.
I think I personally feel the learning curve for PyTorch is much like
Smoother.
smoother
Yeah,
than TensorFlow.
true.
Or we
Yeah,
can actually for the first two assignments, I think PyTorch is not required for the first two. So we
yeah.
can even try for Swift also, like if anybody is interested.
Yeah, so these are which are totally open. Like if anyone is interested in working parallelly on some other uh, library, we can do that. I want to give TensorFlow a try because I have been working mostly on TF than PyTorch. So if anyone else is interested in TensorFlow, we can collaborate and do it.
I'm pro PyTorch for now.
Okay, sure.
This mentions he's okay with TensorFlow. The reason I am okay with PyTorch is PyTorch has pretty good backward compatibility,
Okay.
contrary to TensorFlow. So like the API is constantly being deprecated.
Yeah, that happens a lot
So
in
that scares me a lot because I'm always messing up my installation.
yeah, there are a lot of updates that keep going on in TF. Yeah,
For
but
sure.
hopefully with TF, I think they are doing very good work in stabilizing few things. I think it's hopefully that would turn out much better. Yeah.
For sure. Sagar has mentioned he's okay with both PyTorch or TensorFlow, and
Oh,
in his
great.
opinion, it's about getting to play around with the concepts. Really.
Yeah. Okay. So what else do we have?
Avinash, just a quick question here. So, like,
Yeah,
did you
Sam.
look into the these projects they did at the end of the semester? So, like, is it possible for us to take one project and try to implement it ourselves or something? Did you take a look into that?
Yeah, we can do that.
Okay.
But I think it would be too early for us right now.
Yeah, that is true.
Yeah,
Yes.
yeah. But yeah, we can pick up some project and start working on it. These are I think the 2019 things. If they're already available here, I think they should give us some good project ideas. Yeah.
Do you know what sort of projects can we expect to be able to like work upon after going through this?
Yeah. So if you see here, question answering kind of things,
An automated neural network QA machine, that is right.
yeah. And what else we have here? We have translation. I'm
Yeah,
more
we
into
have like
this.
a sequence to sequence model and
Yeah.
question answering. Mainly
Yes.
attention is also there.
Any
Yeah.
transformer e thing, bird-ish stuff.
I'm not sure.
Can you just repeat the question?
Any Bertie stuff, Bert-ish stuff.
Okay.
I
Okay.
I th- I think they must have surely covered it in some lecture. I believe, but I'm not sure at the moment.
But yeah, interesting to know that like that's certainly within reach. Once we
I can see like February 21 transformers and something.
Yeah, and also
Thanks for
in the previous version of the course, after 50 minutes or something like that, they had this very short break where one of the students or the TAs would come and present a paper. Yeah, I'm not sure whether they continued that in this course, but yeah, some of the TAs or students from the class will be there for a few minutes and they'll give a quick presentation of some paper or something like that.
got it.
Yeah. So is there anything else that anyone wants to comment or suggest here?
So for context, like today's meetup is really about our own logistics. So deciding how do we want to go about the course. So just a comment for the audience. And really like understanding the syllabus, what can we expect to go through, what are we expected to be able to do once we through this course. There are no other questions inside of the chat.
Okay.
So for next week, I think we should like watch the first two lectures and have a look into the assignment also.
Yeah. So we can target 2 lectures, but as
time permits.
yeah, we'll see as someone rightly pointed, some of the lecture contents will be too dense to finish in 1 hour or something. But then we can see what we can do in the time that we have, and then we can always finish the remaining stuff in the next week.
Sure.
Yeah. So for the next week, I can take up lecture 1. And I can do the lecture 2 as well. I mean, I can get things ready for that, and we'll see how we go about time. And what about assignments and code?
I'm interested in the assignment to look into that, and I can run through it next week.
Sure. Yeah. So even if someone else is even if I say that I will be covering lecture 1 and lecture 2 in the upcoming week, and someone else wants to do it, we can always collaborate and split the time among ourselves, and we can do it. So please feel free to reach out. We'll be sending out the plan sheet in some time, so that you can just put your name against the lecture that you want to present or talk about.
Yeah, I think it'll just be an Excel or Google sheet. Maybe
yeah. Yes. Yeah.
I think that is kind of one version of it is already shared. I saw somewhere.
I need to add the 224n options out there. So we'll reshare. But it's there in the FastAI channel. It's pinned to the channel, the older one.
Yeah.
We still have about another half an hour for today's meetup.
Yeah. Okay. Then maybe I can tell you people about another paper. Is that fine?
Sure. Who would love to hear?
Okay.
Sagar also says yes in the chat.
Okay.
There's this, I'm not sure if it's called the bird killer, but Excelnet paper that has just come out for the NLP.
Yeah, I see a lot of that on Twitter. Like people are talking about that. Yeah, I haven't looked into that yet though.
Interesting.
Yeah.
So
can you also? Yeah.
Yeah, we can. Maybe if anyone is interested in doing the paper presentation for Excelet for this meetup, please reach out to Vinash or me again.
Yes, please. Yeah. Yeah, so I'll be presenting this paper in the next month online meetup, and the paper Rethinking Imagenet Pre-Training, it's by Facebook AI Research. It's more of a study and comparison between how a model, when it is trained from scratch, compare against a model which is fine-tuned with a pre-trained model. Like it's like right now, using transfer learning and fine-tuned model has become more of a standard. Like in fast AI, we have cats and dogs, where we take some ResNet 50 or something, which is already trained on ImageNet, and then we use that directly, or we just fine-tune it by adding some layers on top and retraining only those top layers. Yeah, so that's been more like a standard procedure at the moment. But this paper has done some experiments about how the models which are trained from scratch compare against models which are fine-tuned. So there are some very interesting results from this paper. Like if you see here, what we have, the purple line here, it shows us the plot for random initialization, which is nothing but training a model from scratch. Whereas the gray one here shows us it represents a pre-trained model that uses transfer learning. We can see that the transfer learning or the pre-trained model gets some kind of a head start here. Like it starts with a score of close to 20, whereas a model which is trained from scratch starts somewhere close to 5. That's because when you're training a model from scratch, they start with some random weights, which are often not that good. As you keep training the model, they're going to learn better weights, and you get better scores. Whereas with transfer learning, you already have a model which is trained on ImageNet, which itself is a huge data. And it is at least going to get the things like edges and some common patterns that exist in the data right. It already kind of knows those things, which is why it starts with some better scores even when in the initial epochs. So this is one thing. And there are some very good, this paper reports some very good things, like some prior work on training a model from scratch was done. But for that, they came up with some specialized architectures uh, to support training models from scratch. But the results that they got were not as good, or comparatively, they are much worse than that of transfer learning. But in this research paper, in this work, the authors, uh, the researchers from Facebook AI, instead of going for some specialized architectures, they used existing architectures like Mask RCNN. They used that as a baseline model. And instead of making changes to the architecture, they just made a couple of changes, which is they trained the model for many more epochs. Like the number of epochs are more. And that makes sense, because when you're starting with when you're training a model from scratch, if you have to get decent accuracy or decent scores, you have to train the model for more number of epochs. So that's one thing which they did. And another thing is, instead of using batch normalization, they used some other alternatives for that, which is synchronized batch normalization is one thing, and group normalization is another thing. So just by making these kind of minor changes, they were able to train models from scratch, which gave results that are very comparative to that of fine-tuned models. And also they have they did all these experiments on Coco. What they noticed is that even with 10% of data, uh, I think 10K images, yeah, only with 10K images, they were able to train a model from scratch. And they reported results which are very close to that of fine-tuned model. So I will be discussing this paper in more details in the upcoming monthly meetup. But what really interested me in this paper is that we keep there are a lot of new things that keep coming up like every day, and there are so many novel things that keep coming, but there is also a need to study the existing techniques and methods in more detail, because only then I think we can figure out loopholes, if any, or maybe we can come up with methods which are much better than what we have now. This paper does exactly that. Training a model from scratch is something like which we don't often think about doing. Yes, there is a constraint with time and computation, but if one can assume that time and computation is not a constraint, and if you are given enough amount of computations, maybe then we should also experiment with training models from scratch, because in this case, for a certain experiment settings, the authors have reported that training a model from scratch has actually given slightly better results than training a model in fine-tuned paradigm. So yeah, that's about this paper. I'll be discussing this more in the next meetup. So if anyone wants to ask anything about this.
Yeah, just a quick question. So
Yes, Sam.
when training from the scratch, so you said like a little bit better result. So is the result from the same number of epochs for both of them?
No, for training from scratch, the number of epochs are more. Like as I said, the settings remain the same. You have to train for more number of epochs, and you have to make some changes like batch normalization. You have to replace that with a group normalization or synchronized normalization. With these changes and training it for more number of epochs, they reported that this has actually given better results. Let me show it to you. Yeah.
So did they do some comparison, something like, okay, like let's say for both of them same number of epochs and still the like without pre-training it gives better result? Is there something like that?
Yeah, so nowhere in the paper did they say that they compared it with equal number of epochs, because I don't think that would be possible. Like if you're choosing to train a model from scratch, then for that to give anywhere close results to that of fine-tuned model, I think we have to train it for more number of epochs. There is no other alternate there. But here, as you can see, so if you see this plot here, yeah, so in this setting, I think the purple one here is random initialization. Yeah, if you see here, what they got with random initialization is 48.6, whereas with fine-tune, they got 48.3. Okay, so it's very slight. It's just 0.3 difference. But as I said, the most striking thing about this paper to me is like studying something which is some method which is left out in more detail just to get insights like this. There are some other interesting results as well. Yeah, so I'll be covering that in the meetup anyway. So
the paper looks interesting.
Yeah, it is. And nowhere in the paper did the authors conclude that training from scratch is better than transfer learning. No, they didn't say that. They were just trying to say that if time and computations are not the constraints, we should also give a thought about training a model from scratch. Because in this case, we can see in a certain setting, we got a slight improvement like 0.3. If maybe we can if we can find some other ways of doing it, maybe we can get better results for certain data sets or certain settings with training from scratch, and that would make a difference. Yeah.
Yes.
I mean, for us, like regular setup users, it wouldn't be practical, right? If you have just a single.
Not at all practical. Yeah. So for the regular, I think developers, researchers like us who don't have.
I'm talking about people having, for the audience, for some more context, people having DL boxes worth $2,000, $5,000, $6,000.
Yeah.
this doesn't stand a chance. Please don't train anything from scratch.
No, not at all. It doesn't work. Maybe just to run some experiments, I guess maybe we can start with some. We can just use a subset of cats and dogs and see, train it from scratch and see how it goes. We can give
Not
that
for
a try.
Imagenet, not at all.
No, no chance. It's not going to work. Yeah.
Also, quick comment that one of the I think the first author is Kaiming He, who also was an author of the Kaiming He initialization paper, which is really highlighted in the part 2 that's coming out next week.
Oh, okay. That's good.
Hey, Avinash, 2 questions. First one is, any insight with the layer normalization that they talk about? And a
Yes.
follow-up to that is layer normalization also kind of used in the pre-trained, the fine-tuning network in their tests?
Yeah. So
Or is
you
that
want,
the trick?
yeah. So as I said, the changes are that they did not go with any specialized or novel architectures. They used the regular baseline models. And the changes which they did is, instead of using batch normalization, they tried group normalization and synchronized batch normalization. The reason for this being, when you're working with image data, like when we have inputs which are of very high resolution, due to memory constraints, you can only use the batches can be like very limited. You can only go with certain limited number of images per every batch. So batch normalization is kind of directly dependent on the batch size. The bigger the batch size is, the better results you're going to get. But with image data, and when you're training from scratch, it's not quite possible, because you have to start with fewer number of images for every batch. So what they do is they tried group normalization and synchronized batch normalization. So group normalization is kind of it's independent of the batch size. That's one reason. And when it comes to synchronous normalization, what they did was they used multiple GPUs, multiple devices, and then that kind of, so the total or effective batch size is much bigger than the normal batch normalization. So that's how they tackled, this is the major thing which, coming to the architecture changes, this is the major thing which they did. But besides that, they didn't really go for anything else. And they also make a point of that in the paper, saying that there were some prior works which were done where they tried some specialized and new architectures, but that didn't really give them any comparative results. So for this, to be fair enough, like comparing transfer learning outputs with very specialized architecture doesn't sound fair. So they make a point that we are only going to use what we already have, what we're already using for like the regular tasks, and we are going to make some minor tweaks to that, and we are going to obtain comparative results. That's what they were trying to convey in this paper.
Cool, thanks.
Avinash, there is a question in the chat that can you kindly throw some light between difference between batch norm and group norm?
Yeah, so group norm, so batch normalization, as I said, the main difference between batch normalization and group normalization is batch normalization is directly dependent on the batch size. Like when we are training our models on FastAI, like we have like on Colab or something, we set the batch size to 60, 32 or something like that. So if you're working with much when the resolution of your input images are much higher, let's say you're working on some very high resolution imagery, some satellite data or something, then you can't really have much, the batch size can't be so big. That you have to go with lower batch size. That kind of slows the training, but then if you're having higher batch size, you're going to run out of memory. So the problem with batch normalization is that it is directly dependent on the batch size. If you have bigger batch size, you're going to get good results with batch normalization, simple batch normalization. The reason being that let's assume that whatever the server that you have where you're running your model, it can accommodate your entire data in one go. If you have 1,000 samples, you can let's assume that you can set your batch size to 1,000 and you can train your model. In that case, your model is going to see the entire data in one go. That way it knows the entire distribution. It is going to give you good results, but that's practically not possible. So ideally, the bigger the batch size is, the better results you're going to get with batch normalization. But with group normalization, it is kind of independent of batch size, and that way it accommodates even smaller batch size. So that way it helps training a model from scratch.
Okay.
Yeah.
Avinash, could you say a few words about group normalization, what that is?
I didn't read much about it. Like, I do know that, okay, let me open. I came across that in this paper, and then when I searched for it, what I found was that it is kind of independent of batch size. That's what I found. But yeah, I'll take that. Anyways, it is one of the points that I took note of to cover that in my upcoming meetup where I'll be discussing that. And maybe then I can answer that question in more detail.
Okay, thanks.
Yeah, thank you.
And what do you mean by the upcoming meetup? Do you mean by next week's?
No. So we also have this monthly meetup, right? The Americas meetup and the other one. So the next monthly meetup is on July 17th. Yeah, July 17th or 19th. Yeah. So there I'll be presenting this paper and I'll be covering all these things in much more detail.
Is this the TWiML AI podcast?
No, it's not the podcast. We also have online meetups where you can go and present any paper. Either it could be a paper which you have come up with or something which you came across and want to present to the community. You can do that.
Oh, okay. Could you provide a link, please, on the chat?
Sure. Yes, I can do that.
Thank you.
Yeah. I'll share that. Yeah. So are there any other questions, or if anyone else want to present anything, then I'll stop sharing so that you can go ahead.
Just want to point out that we'll be running the part 1 revision group. That is 2 lectures of fast AI, really a revision for most of us each week in conjunction with this meetup every week. So those who didn't attend the fast AI meetup, this is a note to them.
Yeah, so that happens at 9 and this happens at
9
10,
a.m.
right?
Pacific time or to 10 a.m. Pacific time, and this is from 10 a.m. to 11 a.m. Pacific time.
Yeah, okay, yeah.
If that timing doesn't work for you, we're following the same exact same agenda each week in the DSNet community also. So exact same material will be covered, exact same agenda at 4 p.m. Indian time. So if that works better for you, please feel free to jump in. I am organizing both the meetups. You can expect the exact same thing.
Sure. Thanks, Anya.
Sure.
So is there anything else that anyone wants to discuss? We still have 8 minutes left in this.
Nothing in the chart so far.
Okay, sure. Then, yeah, thank you all for being here. We'll be sending out the Excel sheet, and feel free to post your name against any of the assignments or the lectures that you would like to present. Yeah, thank you all.
Thank you so much, Avinash, for hosting.
Thanks, Anya.
Let's just wait another 1 or 2 minutes and then end.
Sure, yeah.
Have you gone through, personally, have you gone through all of the lectures yet?
The NLP thing?
Yeah.
Yeah, as I said, but it was long time ago. Like
Okay.
it's been more than a year easily. Like I went through the 2017 class lectures. Yeah.
So personally, like, are you interested in going through it again? Are they that good?
Yeah, they're really good. I was actually there was another with Daniel and some of us. We formed a group and we thought of going through a CS224, but that didn't happen. So yeah, I think this time I'm all in for that. Yeah.
Awesome. We all are, definitely.
Yeah.
Rijul has asked, are we covering one lecture a week? We're aiming for 2 lectures next week. From there, we can see as time permits.
Yeah, but yeah, so we're not going to rush anyway, so don't worry. We'll make sure that
if Avinash feels it's being rushed, we'll take our time with it.
yeah, that will do. Yeah.
We
So
sort of
yeah.
sorry,
Yeah. So there's if there are any like new people who joined like for the first time, so it's more like a study group. There is nothing formal about it. So everybody can chip in, and if you have any suggestion or if you feel that we have to slow down a bit and cover things in more detail, you just have to let us know and we'll take it up accordingly. No problem with that at all.
it's more about following the 1 hour constraint because we don't want to set another time slot for all that are comfortable. That's the issue for us.
Yeah.
Or the constraint challenge for us.
So like it happened today, like in the upcoming weeks, I don't think I can start the meetup until the previous session ends, right? Or can I?
I'm not sure if that's...
Yeah, because today when I was trying to start the session, it was saying that some session is already going on. I have to end that and then start this, which was why I didn't do it. I thought your session is already going on and that would get interrupted.
I mean, it kind of makes sense, right? So quite a bit of us would be interested in joining booth. So like,
yeah,
it's up to the person hosting the first day meetup that they really need to end it within time, because the second one can go ahead a bit overboard, but first day on time.
Yeah, maybe we can like check that whether it works that way or not.
I'll check that out.
Sure.
I don't think it would, because that's how Zoom is designed. It might, but let's look into that.
Yeah, we'll maybe give it some random trials and we'll see. Yeah.
Yeah, I think it's good to have this separate meetup, because that way it's a natural check on people's tendency to go over, so that So this meeting starts up at exactly 10, and everyone who's at the previous meetup knows that they better finish up their business and get going to this one if they want to join.
Definitely. All right, the chat is clear. Thanks, Avinash, again.
Okay. Yeah.
And thank you everyone for joining. We'll see you all next week from 10 a.m. Pacific time for NLP and 9 a.m. Pacific time for first day revision.
Great. Yeah. Thank you all. Have a good night and have a good day. Yeah.